Thank you, everyone who showed up on this last session of the fabulous OSA Con, as it's called. Um, I'm really excited to be presenting DataHub and data contracts, two extremely buzzy topics. I'm Shirshanka Das, CTO and co-founder of Acryl Data. Prior to this, I was at LinkedIn for a number of years, 10 plus, where I spent pretty much all of my life making data easy to use by building projects like DataHub, which allow data to be made easily discoverable. And at the same time, also worked on making data hard to use by working on projects like DataHub, which allow you to have data governance and data privacy initiatives tied into a central metadata platform. I used to tweet at Shirshanka, and now I guess X at Shirshanka occasionally, but I'm, of course, always found on either LinkedIn or the DataHub Slack. Well, let's get into the talk. What is the DataHub project? You probably have heard of it, or probably this is your first time encountering it. DataHub is an open source metadata platform that enables data discovery, data observability, as well as modern data governance on top of a high fidelity metadata graph. And for a lot of people, that's a lot of words, and I'll hopefully explain what I mean by these different topics over the next few minutes. Acryl is the company I founded. It's advancing the DataHub project. It came out of DataHub, the project came out of LinkedIn, and commercially, it's available as Acryl Cloud. So if you want to kind of super simplify down what we do, we build a high fidelity metadata graph by connecting all of the data assets that you have with all of the people that you have that are working on these data assets or consuming these data assets, and connecting that up with all of the logic or the code that exists that is actually consuming or producing these data assets. And on top of that, we build multiple different capabilities and use cases on top, whether you're an organization trying to just enable your data teams to quickly understand where all the data is, how it got there, and get to productivity outcomes. You can use it for discovery. If you're an organization that is struggling with data quality issues or data pipelines breaking all the time, you can use it to empower and enable observability or data quality use cases. And if you're an organization that's much further along and is dealing with understanding how do we govern our data well, how do we apply business concepts and semantic layers on top of this raw technical data that we have, you can essentially use it for governance use cases. And some companies use it for all three. So it's a pretty interesting project, kind of like a one platform that accomplishes multiple use cases. It is also happens to be the number one open source metadata platform, using all of the standard metrics. And a lot of it is based on both its maturity, but also its strength in a few different dimensions. Integrations come out of the box. So whether you are an old school stack sitting on top of Teradata and Netezza and Hadoop, or if you're slightly more modern cloud native stack, or you're using a lot of ML and data science technologies, odds are there's already an integration for those tools available in the open source project. And so for a lot of organizations, they're able to get started and build very quickly. And that results in a lot of really great adopters. We have companies like Stripe, Pinterest, PayPal, Netflix, and others that are kind of actively using and contributing back into the project as well. So it's a phenomenally successful project, and we're having a lot of fun building in the open with the community. So what does the project actually do? Well, it's actually built off a lot of members as well. We are primarily hosted on Slack. I mean, GitHub is where the code lives, and Slack is where the community lives. Almost 10,000 members, and a lot of organizations are part of it. A lot of contributors. It's a pretty mature project, so close to 500 contributors and a lot of GitHub stars. And we have some basic anonymized telemetry that tell us that we've got more than 2,000 quick starts. So this is when you just download DataHub and run it locally on your laptop that are being run every month. And in terms of deployments in production, more than 1,000 deployments of the DataHub platform in organizations around the world. So it's a extremely widely adopted and widely deployed system. But now let's talk about what it actually does. So you'll hear me talk about metadata probably 100 times or more in this talk. And so it's useful to kind of start by saying, what does Shirshanka mean when he says metadata? And what are all these things that we talk about when we say metadata? For people who are photography experts, metadata started out there when you take a picture, like an image, and that image has a little bit of metadata associated with it that says where you took it, what was the focal length, what was the aperture, and things like that. And that was kind of the first implementation of kind of portable metadata that worked across cameras and across devices and across tools. And what we are setting out to do in many ways is kind of implement a version of that concept for data. And that obviously starts by standardizing these concepts across all of these different tools. So our metadata graph, of course, therefore represents the complexity of all of these different things that we call data or are related to things we call data. I mean, you've probably had a lot of talks yesterday and day before yesterday from folks in the superset community or folks in the hoodie community. And these are all concepts that we model in the metadata graph. So things like data sets, tables, streams, folders, columns, queries, dashboards, pipelines, processes, charts. And as you go further outwards from these, fundamental technical concepts, you see slightly more logical concepts like tags and terms. And then more recently, even more logical concepts like data products and domains and data contracts have made an entrance into our metadata graph. So as you might imagine, this metadata graph is continuously growing, and DataHub as a project is continuously expanding to include these concepts in its representation and in its vocabulary. I started with saying that DataHub tries to address three problems: data discovery, data quality, and data governance. And we'll start with just talking about data discovery. It's a very well understood problem, and yet many attempts have been made to solve it and have failed. In fact, I myself tried to solve it a few different times at LinkedIn and kind of went through a painful journey of failing a few times before I succeeded. So the first thing that I noticed among the attempts of my own and my peers that had failed was that we tried to do things in a slightly more batchy manner. So a lot of our initial attempts at metadata was, connect up to systems, extract metadata out, and that kind of crawl-only ingestion leads to stale metadata, and that doesn't lead to trust in your metadata. At the same time, we tried to take all of this metadata and put it in one system, but for non-technical users, a lot of this metadata is not very intuitive. And on the other hand, for super technical users, just having fluffy, cosmetic, business human documentation isn't enough. They want to get into the details. When you try to drive operational use cases on top of metadata, you end up failing with a lot of the solutions from the previous generation because they don't have any approaches to acting on changes in metadata. So if your metadata is changing all the time, your data is changing all the time, you need to be able to react to that change as it happens. I mean, even as I'm giving this talk, there's probably a pipeline that ran and produced some data, and maybe it's good data, maybe it's bad data, and maybe someone needs to know and do something about it. But if we have kind of a static, one day at a time approach to all of this stuff, we're never going to be able to actually have a data ecosystem that is continuously evolving and continuously adapting to how things are changing. And so a lot of those kind of intuitions and insights and learnings were really driving the architecture and the product experience in DataHub. We basically think about the way in which we are different, or the way in which this project has approached this problem differently, in three kind of pillars. The first is what we would call metadata 360, or the ability to actually include all the different kinds of metadata in one single connected graph, whether it's technical, like schemas and columns, or whether it's operational, like the actual audit log or the actual execution log of an individual system, or whether it is business metadata, like who owns this and which domain is it part of and which teams are operating on this particular high-level data product. Combining all of those into one unified experience leads to a lot of good things. The second principle that we've kind of adopted is shift left. And this is a common principle that is known well in the security domain, where you want to make sure that anything that you're collecting and curating, you try to declare and collect it wherever it's getting created. So for example, if I want documentation on a particular column in a table, instead of waiting for downstream teams to come into a UI and click buttons and put that documentation in, why don't I actually have the developer have the tools in their stack where they can actually declare documentation when they are creating that data or that schema in the first place? I mean, it seems kind of simple when you say it like that, but it's kind of funny that we've not taken those standard software engineering practices and we've not really applied it to metadata till now, right? So we really put a lot of emphasis on shifting left and making sure that whenever data artifacts are getting created or authored, we provide the tools and the technologies for you to collect metadata at the source. And then last but not the least, we are event sourced, meaning our metadata is continuously flowing. And these real-time metadata events actually enable machine-to-machine automation, which is different from a classic data discovery or a data catalog solution, which is generally meant just for human consumption. Once you actually have event source metadata, you can do a lot more with it, and it can become really a critical part of your data stack. So these are the three pillars around which all of the DataHub architecture is built, and all of the product experiences and automations are built as well. And for people who like architecture pictures, this is what it looks like. You've got all of your data sources, and depending on your stack, you might find some things here that resonate with you. You might be using Spark or Airflow or dbt or Snowflake or all of them, or you might be using data quality tools. And in all cases, DataHub is essentially either listening by pulling and extracting metadata from these systems, or these systems are actively pushing metadata out from those systems. Anytime an Airflow job runs, it can push out an event. Anytime a dbt run happens, it can push out events. Anytime a schema gets checked into a GitHub repository, it can push out events. And all of these events essentially become a fire hose of metadata changes that are getting pushed in to the DataHub platform. And the DataHub platform essentially ingests it, harmonizes it, applies. You have the ability to apply continuous refinement and monitoring on top of this as well, where you can refine things, you can connect dots where they didn't exist before. But all of this is also available as a metadata change stream for downstream actions to get created. So maybe a data set was just classified as PII and you have to go lock down access to that particular asset. Or maybe a data set just landed or a table just landed and you need to fire off a data quality job. Or you need to just notify someone that a schema has changed in a backwards incompatible manner. All of those capabilities are available. All you have to do is tap into the change stream and build actions that you can use to drive downstream capabilities. But that's not all. In addition to all of this programmatic and automation capabilities, you also get a beautiful data discovery application, which is built on top of a GraphQL and OpenAPI set of services that allows you to essentially build a delightful discovery experience for your human consumers to be able to browse and understand and discover new assets that they should be interacting with, or look at assets that they own and understand how they're getting built and maintained. A different way, so this is kind of a more stream-oriented way of looking at how metadata comes in, gets transformed, and then factored out into either programmatic downstreams or human consumption. A different way of looking at this architecture is by thinking of it as a control plane for data. And a control plane for data actually ends up having a very similar set of needs. You have a data plane that your data stack contains, and you want to be able to continuously listen to things that are happening in that data plane. And at the same time, you want to control things that need to happen in that data plane. For example, I might want to register a logical specification that says this particular table should always look like this, or that this particular table should even exist. And the control plane can register that control specification, and an operator can actually listen to that registration and go provision that table for me. or it can go set up a data quality rule for me, or it can go and provision some tag-based access masking policy for me. In other words, you can have logical specifications get registered to a control plane, and you can have operators that are registered for those events and can go make those changes happen in your physical data plane. What is interesting about this architecture is it needs exactly the same kind of primitives that DataHub has built over the years in order to achieve this kind of free-flowing metadata architecture. And I'll get into why this is interesting later on in the talk, because it actually enables the foundations for building data contracts and for enabling data contract enforcement. Cool. So I talked a lot about DataHub, and I talked a little bit about the discovery experience in DataHub. I'll spend just a few minutes going over it in terms of how it looks and feels. The real way to experience it really is to actually download the software and to run it yourself. You can connect it up to your organization's data sources, and you can actually experience it for yourself. We also have a demo DataHub instance that you can just find. Just find us on Slack or go to the datahubproject.io homepage, and you should get all of your resources that you need. But this is what it roughly looks like. You get a homepage, you drop into the center of the homepage, and you have a search bar. You can search for stuff, or you can actually start browsing based on domains, or you can start exploring your data based on categories. And once you search for something, you get back kind of a classic detail-oriented list of all of the things that matched, whether they matched the name or perhaps they matched descriptions or columns or things like that, as well as kind of a way for you to filter down by the asset that you really care about. So perhaps you're just looking for dashboards, or maybe you're just looking for dbt assets, or you're looking for airflow pipelines. All of those kind of capabilities are available to you. And the moment you filter down and look at the specific entity that you care about, you can dive in and explore further. So obviously you can look at its schema, you can look at all the fields, you can look at how they're getting used, which ones are most popular. You can also look at lineage, which is kind of one of the most common things that people look at, both at the table or entity level or asset level, as well as at a column level. So you can basically, in just 2 or 3 clicks, get to a point where you're able to understand that maybe there's one column that you're about to change the definition of, or one column that you're about to change the contents of, and you're able to quickly understand who all are you going to impact, or what all is upstream of you that can impact this column that you actually use in an important dashboard. And from then on, you can find who the owners are, or you can send out notifications to let them know that a change is coming. Stripe is a very interesting adopter of DataHub. They've actually built a timeliness experience on top of it. So you might be running a large data pipeline ecosystem with Airflow or some other orchestrator. They've actually integrated all of those operational metadata into the catalog experience itself. So in the discovery experience, you're not only looking at data assets, dashboards, charts, but you're also being able to look at pipelines, and you're able to look at how they have done over time. Do they land on time? Do they usually have errors? When do they usually finish? Things like that. And this leads to a lot more usage and adoption of this central kind of data pane of glass. A lot of people are usually very interested in how DataHub extracts metadata, so I usually spend a little bit of time talking about it. We have a combination of crawling as well as pushing-based integrations. Crawl-based ingestions generally get built against data at rest. So for example, you might have Snowflake or Tableau or Power BI or any of these systems, which are just repositories of assets. DataHub actually comes out of the box with a very flexible Python-based ingestion library that essentially can go in and incrementally crawl your data source. So whether it is being able to get its schema of a table or all the tables, being able to parse audit logs, parse SQL, being able to profile data, all of that stuff essentially gets done incrementally and periodically, and then pushed back into DataHub as events. Similarly, you can have active systems like Spark and Airflow, or even GitHub Actions, pushing events out whenever changes happen. So we have like a Spark agent, we have an Airflow plugin, all of these systems that are built for knowing when something interesting happened and then pushing that event out. So in the case of Airflow, it would be, hey, this data job just ran and it consumed this table and it produced to this other table. Or in the case of Spark, it would be this Spark job just ran and this is what the DAG did. It processed these folders and it wrote to these other folders. And by the way, it took 5 minutes to run or 5 hours to run. So those kind of insights are hugely valuable because for someone who's consuming, they could either be interested in whether that Spark job is doing well, or they could be interested in whether the table that it produces is doing well. And all of those insights are available in one system once you connect all of these things together. So data discovery is something we talked about, and kind of I covered how DataHub kind of addresses the data discovery problem by essentially allowing you to stitch together metadata from every single system you have in the most easy and flexible way. But data discovery is not the only problem that is hard to solve in the modern data stack, which is very fragmented. Data quality tends to be a pretty hard problem to solve as well. And it's hard for multiple reasons. One of the reasons is that data itself goes through a lot of different stages of transformation before it gets to wherever it needs to go. So in a lot of companies, we see a pipeline similar to this, where you might have a Kafka topic that is your event stream that's probably getting ETL'd into a lake. Maybe that's Hoodie. You might be running some amount of data quality checks there. Some of those checks might be running upstream in the ingestion system itself. And then maybe you're loading it up into a warehouse, and maybe you're running some more tests over there. And then maybe you have some kind of anomaly detection system to check where anything anomalous happens, independent of whatever known checks that you had end-to-end built. In some sense, this is good. We at least have some tools and we can apply them at the right stage, at the right time to do some things. But the problem with this approach is that you have inconsistency in how you're checking things across different tools. You don't quite have a overall picture of what is even being checked and whether this data is really trustworthy. These individual tools have their own answers, their own results locked inside their own systems. So you can't really get a full picture of end-to-end data quality. And so as a result, when you're a pipeline owner and you're trying to consume a particular data asset, despite all of the data quality that exists here, there, and everywhere, you yourself have to maybe defend against yourself by writing your own data quality rules and protect yourself. And that just leads to more waste in terms of maybe you're checking the same thing, or maybe you're forgetting to check something that someone else should have checked. And in an overall sense, we just can still not trust the data that we have. So we kind of looked at it and said, well, here's what the solution blueprint should look like. First, we obviously need end-to-end data quality visibility. So the ability to actually see data quality end-to-end. Well, cool. We already have a metadata 360 solution that should help. The second thing we noticed was data consumers are often reactive and being forced to take account to be inflicted by problems that exist that an upstream producer actually created for them. As we said, well, we know how to do this. We've already worked on moving accountability upstream when it comes to other kinds of metadata. So why not also move accountability upstream for data quality definitions via shift left? And then finally, we noticed that despite all of the automation, it wasn't easy to know at an instant in time whether this asset is high quality and should be consumed or not. And we said, well, we have an event-sourced metadata platform. It's real time. You can basically know the status of anything within a few seconds of it happening. So that should allow us to enable instant action, instant ability for you to essentially stop processing data if it is known to be bad, or start processing data if it is known to be good, the moment it's known to be good. And so with these three kind of capabilities, we kind of produced this solution blueprint for solving this kind of technically hard problem that we are facing as an industry with data quality. And data contracts actually have been kind of an important part in this moving accountability upstream part of that solution. Right? A lot of people talk about data contracts as being living between the operational plane and the analytical plane, and that's a great place to apply it because a lot of data is generated in operational systems, sometimes in event tracking systems, And it's useful to have data contracts that kind of ensure that data is of high quality before it lands into the analytical plane. But in general, data contracts are useful anytime there are handoffs between teams, where the handoff artifact is a data asset or a set of data assets. So we actually asked ChatGPT, what is a data contract? And ChatGPT gave us a very reasonable looking response, like it usually does. Some of the things were very valid and very good. It's an agreement, specification, defined structure, format, and semantics of data, exchange between different systems or teams, serves as a mutual understanding. All of that stuff is great. We added one more thing that ChatGPT didn't add, which is the data contract must be verifiable. So if it's just a data contract that talks about things we should do or promises that we should be making, but if it's not actually enforceable or if it's not actually verifiable, then it doesn't belong in the contract. So with that kind of lens, we looked at what are the verifiable things that people want to protect. And we said, well, schema, meaning the structure of the data, column level nullability, data checks, operational SLAs. These are things that we can actually check. These are things that we can actually validate whether they're being met. Things like ownership, things like documentation, things like tags, those are useful to understand what the asset is about, but that's more like business metadata, not exactly something that would be part of a data contract. It could perhaps be part of a data product specification. This is a data contract talk, so I'll not talk about data products and how we represent them in DataHub, but that's where that kind of metadata goes. And for data contracts, what we said is, well, data contracts are essentially a bundle of assertions. Those assertions are things that you can validate, and data sets essentially relate to those assertions. And that's kind of how we modeled data contracts in the DataHub metadata model. So we think of it essentially as a control specification. So quick nod to kind of how I talked about control plane. We think of it as a control specification that is registered with the control plane. And then the control plane turns around and makes that control specification actually happen. So this is an example of what a data contract would look like in the UI. But logically, how we think about it is it's a first-class citizen of the metadata graph. It is a bundle of assertions. It represents an agreement made between the producing or the owning team and all of their consumers that this is something that the producing team is going to stand behind. And it is represented both in a UI-based manner as well as with a programmatic assignment via a YAML spec. So in terms of kind of the life cycle, and I'll get into more details about what the data contract looks like in just a bit. We announced it in May 2023, and there are versions of it that are already out in the open source DataHub product, and a slightly more rich experience that's available in the actual cloud product. So what does the data contract lifecycle look like? In our opinion, data producer creates one of these specs, checks them in. We'll talk a little bit later about how this spec might even get created in the first place, whether we can give the data producer some help to produce that first spec. But at a high level, a spec gets produced, it gets checked in. Those definitions are then synced with DataHub. That becomes that central control registry for data contracts. Now, data quality tools can actually start producing results and reporting on the individual assertions that are part of the contract. Acryl itself also comes with a data contract operator that can respond to data contract registrations and start monitoring things on its own. Or you could bring your own monitoring tool. You can kind of pick and choose what you want to use. But in all cases, the results flow back into the main metadata graph. And then you can basically see whether the contract is being met or not. And if there are changes in those definitions, those changes can be negotiated out in DataHub directly, or you can negotiate it over a pull request. In either case, there's bidirectional sync capability. So whatever the final agreed state on the contract is, you can reflect it back into your source of truth, which is probably your Git repository. In terms of how we built it, a quick sneak peek into kind of the technical underpinnings behind it. DataHub already supported assertions before we got started working on data contracts. So we already had support for saying, here's an assertion about a table, or here's an assertion about a column. And then associated with those definitions, you can publish events. So you can say things like, this particular assertion failed, here's the time, and here's some results associated with that failure. And you can publish those things from dbt. We have automatic support for dbt tests. You can publish them from grid expectations, or you can actually publish this from any of your custom DQ systems as well. It's a very simple API. All you have to do is instrument your DQ system to publish this. And the moment you do that, it shows up in DataHub as assertions. So we're not talking contracts yet, just pure assertions showing up on the dataset or the table entity page, showing you that things are looking good or not looking good, along with the timeline of how things were performing. But moving on top of that is the data contract. So the data contract essentially in its persistent form is an open source YAML specification. It contains both a YAML specification for what the entity looks like, its schema, freshness, data quality, all of those capabilities are provided, and you get a friendly CLI that you can use to load it up into DataHub. This is what a data set looks like when it's meeting all its expectations. Contract is passing. You can query the GraphQL API and you get good results back. And when it's not passing, that's what it looks like, failures, et cetera, et cetera. But that's not all. You can take those data contracts and then, as I described, shift them left into GitHub directly. So we have GitHub Actions that can open a PR against your repository and can basically give you a summary of what the changes were, and you can then accept them, at which point it becomes kind of committed into the main repository. To help, and this is where I get into kind of Acryl stuff a little bit, moving on from kind of the open source capabilities, Acryl Observe can actually use monitoring to generate a data contract. So to help your data producer write their first data contract or to keep it continuously evolved as the data itself changes, we basically use monitoring and anomaly detection to essentially predict what should the schema look like, what should the freshness proposal look like, and what should be the data quality checks that you should be setting up on these assets in the first place. So the producer gets that proposal, they can accept it, edit it, et cetera, et cetera. And once that's checked in, it actually starts getting evaluated and enforced. So that's kind of the end-to-end cycle, all the way from definition, proposal to definition to management and then enforcement. There are a few different kinds of solution patterns you can do with this. You can build your own. You can write a data contract operator that listens to the change events and does your own initiate monitoring or enforcement. And then you just have to report it back. So you can use it for doing schema checks, schema provisioning. You can use it for doing SLA monitoring. And you can use it for pretty much any kind of assertion that you want to monitor and register. And that's the end of my talk. I know it was a pretty fast talk about the end-to-end story around data discovery, data quality, and how data contracts play a pretty important part in moving accountability upstream and applying software engineering practices to this discipline. We are, of course, building this in the open with the open source community, and we'd love to have you be part of it. So come join us. We are at slack.datahubproject.io. And you could also literally join us because Acryl, the company, is also growing, and you could go explore our careers website and join us in building this interesting and exciting project together.